Good afternoon, everybody. Thank you for coming to my talk. I would like to start with a simple story about, so I had one of those moments at home when I was trying to explain to my wife what I'm actually doing at Microsoft. And so we went to internet and I showed as one of the examples of the technologies that fall into the area I'm working on. I showed her OpenID and some sites that use it. And explain, okay, so we can saying, well, but when I register to those sites, why I have to repeat all the information all over again about me? Why I have to type my address? Why I have to type my date of birth, my citizenship, whatever the site needs about me? Why I have to type it every time? It's really not really adding any value to me. It's just, I don't understand why having a single account is important, and I have still to type every information over and over again whenever I register or change that information. I'll say, okay, well, that's interesting. So my talk will be actually showing you one possible way that we believe could be used to solve that problem, so that you actually don't only flow in information about the user, but you can also identify, but you can also flow the additional data about the user along with the message, so that the service doesn't have to query some attribute somewhere or have to keep database about the attributes on each service. So it's it was very interesting, and my wife doesn't know much about what I'm really doing, and she had this nice observation about it, so it was kind of interesting. So what I will be doing today, my name is Jan Alexander. I work for Federated Identity team at Microsoft, and I'm program manager, and I will be going diving deep into Geneva, and I will be taking all with me. And so let's go dive, and I promise it will be fun. At least I hope. So first of all, you probably saw that slide already multiple times. This is what we have around identity in Microsoft. It's a combination of software and services in the cloud. And in this talk, you will be kind of living in those areas. We'll be mostly talking about the Geneva framework, or Geneva server, and the Geneva server will be using Active Directory. That's primary components, but I will be talking about more as well. But those are the primary areas for us. And during the talk, I will be walking you through evolution of application, simple application that's not enabled with claims, doesn't use federation. And during the talk, I will make it federated. I will make it use claims, or make it claims-based, as we call it. And I will be explaining some stuff around that you have to know that I will be then showing in Visual Studio. And then I will be talking some other features like identity delegation and some other things that we plan to do in the future. Some will probably show up in RTM, some will not. I cannot make any promises there. And we will recognize those slides because they are in blue. So first of all, let's just level on some terminology. I assume a lot. It's supposed to be 400 level talk. So just to recollect, basically our architecture, our model is all around claims. And we are flowing those claims across various parties in things that we call security tokens. And there are three major players in that system. One is called claim producer. This is the guy who makes claims. Then there is a claims consumer. This is the guy who's interested in claims, reading them and reasoning about them. And then there is a requester who requests claims from producers and sends claims to consumers. This is the guy, usually a user or some client machine, whoever needs a service is usually playing that role. And the consumer is, we sometimes call it relying party, and usually the provider of the service. And since, as I said, the claims flow in things that we call security tokens, the claims producer is usually called security token service. Because it produces security tokens that contain claims. And I will be mostly talking about those two. I will not be talking about the client much. And there is another interesting talk on Thursday about the client piece. We have a very interesting technology there called Windows Card Space Geneva. So I encourage you to go to that talk as well. There are some, so the words I used are explained on this slide. This claim is a statement made about somebody, and somebody else or the same guy can make that claim. Security token is a packaging structure for transmitting claims over the wire. security token service issues or creates security tokens, and the relying party consumes security tokens or claims contained in those security tokens. It's usually what the relying party is really interested about are the claims. So here is the simple model that we have, that we created in the Geneva framework component for claims and identities and something we call principles. And for those of you who know .NET framework, those names besides claim will probably look very familiar, and that's intentional. So actually we integrated for the first time claims into the .NET framework so that we reuse the existing identity infrastructure that's in place, and we just naturally extend it with claims. So we can use claims whenever you can use the existing identities and it will still work. That's one of the nice things we have done. And it's one of the things that we differ from what WCF did. And I will be talking about that a little bit as well. So as you can see, there is a principle which represents the caller. The caller can have multiple identities. That might sound interesting, and I will be talking about it a little bit more as well. But just accept it for a moment. There can be multiple identities in certain situations. And they are all associated with the call, with the request. And then each identity contains claims. It can be 0 claims, where that means you don't know anything about this guy. And it can be multiple claims, as many as you want. And the claim, simply, you can think about the claim as an attribute, which is a name, it has a value. And also, the other thing that's like different from attribute is an issuer as well. It has an issuer, which contains information about the security token service or claims producer who made that claim. As you can see, all those 3 components are strings. And I will be talking a little bit about how those strings are created, especially the issuer string, which is most interesting. And then there is a subject that points back to the identity. So OK, that's just to set the level on the terminology and the concepts. Now let's really go deep and try to work with that application. So as I said, I will be transforming an existing application that's Windows-based, doesn't use claims, into something that you will see here. So this is the end state that I want to get to. Hopefully I will get to before the talk actually ends. So I have a user. I have a claims producer, which is played by Geneva server. And I have a relying party, which is ASP.NET application with Geneva framework in it. And what I'm going to do, so the scenario is as follows. The relying party has 2 pages. One page is like accessible to anybody. It's the default landing page. Everybody can see it. There's nothing really there. And then there is another page that's like secret page, and only certain individuals can see that other page. So there is some authorization logic in the relying party. And the interesting stuff is that in this scenario, actually only people who have certain shoe size can see that page. Well, that's kind of interesting, right? So shoe size, well, we haven't really thought about it when we designed AD. So how am I supposed to think about shoe sizes in the existing systems? And that's just to illustrate that actually with the claims, you can do even the crazy things like restricting people to access pages only if they have certain shoe sizes. So what I'm going to do is the Geneva server or the security token service, when the user goes there and says, hey, I need a token for this relying party, or claims really, it has a policy that says, oh, if the Bob comes, what I'm going to do, I'm going to issue a shoe size 41, because I know that Bob has shoe size 41. Which, again, that number might seem high, and that's because this is a European shoe size. It's not a US shoe size. So 41 really is something like 8 here. So STS creates a token. In this case, it's a SAML11 token, I believe. It doesn't really matter, because the Geneva framework abstracts everything away, so you don't have to worry about what token format the claims are transmitted. And the user, or Bob, sends that token along with the request to the secret page to the relying party. The relying party, as I said, has authorization policy in it. So it says, well, OK, do you have shoe size 41? In this case, I do, so I get access. So that's pretty much the scenario that I want to get to. So what we start with, something a little bit different. So I have a ASP.NET application that's hosted in IIS, and I have 2 pages that somebody written. One is the default page. The other one is this shoe size only. Shoe size 41 only page. What I'm going to do is, initially, I use Windows. That's pretty much what we do inside enterprises, on-premise. Everything runs inside the intranet, so it's fine. And I'm going to use URL authorization module that's available for me in ASP.NET infrastructure. And I'm creating a simple policy. Now, the first problem, right? So however, what about the shoe size? Windows integrated authentication doesn't really give me a shoe size. So what I'm going to do a little trick here. I'm actually saying the guy who is creating that authorization policy knows everybody who has what shoe size. So he's able to alter the policy right. So he knows I have shoe size 41. So he puts me in that access control list or in that policy on that URL authorization. It's kind of fragile, right? I probably will not grow much anymore, but if we're talking about things like age or some other really dynamic attributes, this becomes really fragile policy. So, but that's what we can do now with Windows. So there is some implicit knowledge about the shoe sizes that's not really recorded in the system. So what I'm going to, as a first step, so we will take it in 3 stages. And I'm not saying you have to evolve your applications exactly as this. This is just for illustration purposes, so because I want to show certain components in our architecture. So first thing I'm going to do is I'm going to make that application claims-based. So instead of using Windows identity or identity and reasoning about roles and usernames, I'm converting the application to think about claims. But I'm not really changing much besides that. So for that, what I need to do is I need to put 2. So I remove the URL authorization because that doesn't use claims, not today. And instead of that, I'm going to put 2 new modules that we provided as part of the Geneva framework. One is about exposing claims from existing authentication types. So we can create claims from pretty much anything. So in this case, I will be creating claims from Windows identity. And then I will be adding the claims authorization module, which allows you to do authorization in similar way URL authorization does, but using claims. And I'm going to put the authorization policy. That's pretty much the same for now, because I still don't have a shoe size claim. But I will be using claims to actually decide who can access. I will not be using SIDs or Windows identities anymore. So let's try it. And cool. So this is my virtual machine. So I have 2 machines. One is a domain controller. It's running the STS as well, Geneva server. And the other machine is running Geneva framework, IIS, and the relying party, the ASP.NET application. So I'm now in that role of developer of that ASP.NET application. And pretty much what I have now is this. So I can go there. This is the default page. Anybody can access, even anonymous users, so I'm not even forced to authenticate. And if I go to the secret page, I can actually go there because, OK, in this case, it's Daniel W., who has the shoe size 41 as well. So he can access. But I'm not seeing much there. There is actually some code that will highlight, show up something when the claims are enabled. For now, it can't. Actually, it proves interesting thing as well. You can write the application in a way so it works without claims and with claims as well. So we can adapt. This is exactly what this page does. And then I can go back, and I'm still authenticated because I was forced to authenticate on that secret page. So that's what I have now. Let's try to change it a bit so that it uses claims. For that, first of all, I'm going to show you very quick the default page. And the secret page is pretty much the same. There is just additional table to show the claims. And the default page, as you can see, actually uses ASP:login name. So this is the classic ASP.NET control that uses identity interface to display the user's name. And as you will see, if I enable claims, it will still work. So that proves the statement I made about integrating claims seamlessly into the .NET framework. And then it shows anonymous if I'm not authenticated, because login name just doesn't show anything in that case. And there is a link, and that's it. So as I said, what we have to do, we have to replace the Windows we have to remove the URL authorization and add 2 new modules, so the claims authentication and the claims authorization module. So let's do that. So I'm going to open the web.config for that application. First of all, I'm going to comment out the URL authorization policy, which is here. So as you can see, it's exactly what I showed on that slide. Okay. I'm commenting that out. And instead of that, I'm adding 2 new modules. So I pretty much prepared everything because we don't have much time, so I'm not actually typing much. So I add this claims authentication module, and then I'm going to add the claims authorization module as well. OK, so now I have 2 modules in the pipeline. But now the last thing is I have to supply the right authorization policy. And for that, I'm going to open, I actually created the authorization policy, which is like my object that you can think about it as part of your application. The other interesting thing actually worth mentioning here is that those authorization and further steps, authentication modules, or the policies for them are actually, I place them in a separate assembly. And that's because I can use the same assembly for ASP.NET and WCF. So it's the other interesting thing we have done. We actually unified programming model of, like for applications, but also for the infrastructure components like authentication and authorization between ASP.NET and WCF. And more are coming. We started with those 2 because they are like the primary programming models for web and services and cloud. And I will be talking a little bit more about the architecture later. So for now, let's try to create some method. So this is a pretty handy method for authorization. I want to know whether the user has a certain claim. The way I'm going to do that is by using link, which is another interesting thing we have done. Since the claims are represented using collections on identities, I can simply use link to query that object in the code. So it looks nice. It's easy to write. It works reasonably well. And as you can see, that's pretty much it. So I'm iterating over all the identities. And for each identity, I'm asking, do you have that claim type with this claim value? And if yes, I return true. Otherwise, I return false. That's it. So it's like the claims-based alternative or variant of the isInRoll method that you have on the principle today. And by the way, isInRoll works as well. I just wanted to show you the code, but I could use isInRoll. But the shoe size is not really a roll, so that probably will not work very well. So next, I need to actually call that method. And this is the core of the authorization implementation. So what I'm going to do is, if you are accessing one of those endpoints that have this requirement for shoe size of size 41, I'm going to ask whether you have, and as I said, I'm still using the name. But here I actually say name, so I can differentiate different things that are attributes about that identity. And I put this one there. And if it's there, you can access, otherwise you can't. And if it's the anonymous page, everybody can access. And I need to remove this line. OK, so, and that should be it. So I added 2 modules, and now, as you can see, I can work with claims. And I haven't changed authentication. I'm still using Windows authentication. OK, so let's try to compile it. Cool. And then let's try to open it up again. So it will still, if it works, access the first page as an anonymous user. And let's go to the secret page. We are, but nothing really changed besides I still don't know your shoe size from the claims because I don't have that information. But I know some other things about you now. And as you can see, this is what we generate as a claims, like out of the box, for Windows identities. So there are some groups. There is a primary group, and there is a primary SID, which is the user SID. And then there is a name. It's pretty much it. And you can notice the local authority here as an issuer. It's made inside your machine. There is something in the machine called LSA that actually made that authentication happen. That's how we refer to it. It's like in .NET, in a Windows Win32 world, you know that name as anti-authority. Because we are extending beyond Windows authentication, we cannot call it anti-authority anymore. Call it local authority. So that's the first step. So I made the application claims base. Wow, OK. So what next? That's not really a big deal, right? So I'm using claims, but the shoe size is only in my head. There is nothing about shoe size in the system. So let's see how we can add a shoe size claim. You can. There are multiple ways to do that. And so I chose this method. I will first add it inside the application, and then later I will move it to the STS. So first, I will be adding it to the application. For that, you need to understand a little bit more about the Geneva framework architecture to know where exactly how it works, so that you understand which extensibility point you can use to add additional claims. And that place can be used to actually go into database that you have about that user, about the users that access your page, or to LDAP directory, or whatever attribute store you have, and fetch information about that user if it doesn't arrive in the token. So I'm sure my example is really trivial, but you can use it for pretty interesting things. And once you add it as a claim, everything in your application will see it as a claim and can reason about it. It will be part of the identity. It will flow anywhere where the identity flows and the principle flows. It's a pretty powerful thing. And you can do that actually beneath your application code. You don't have to change your application implementation at all, like the business logic. So the request comes in. There is a hosting layer that processes it. It can be, as I said, WCF or ASP.NET right now. And anything you will see on that right-hand side on this slide is extensible. All those components are essentially extensibility points. You can mess with all of them on the framework level. I will be just playing with one of them right now. So what happens is we extract tokens, which is information about the caller, from that message. And first thing that we do, and that's optional, like if you use Windows integrated authentication, this part is done in the kernel or in the LSA process. In some cases, it's actually done in the framework. So we deserialize that token, and for that, we need to be able to resolve tokens that, because the token is signed usually by other tokens that represents the issuer, and that signing token doesn't have to be inlined in the token that arrived. And for that, you need to be able to reach out. Oh, what are the issues that I know about? And do you actually know about this reference? Are you able to resolve this key? So this is the token resolver. You can provide your own way how to implement this. And what gets back is issuer token. We use it to verify the signature on the token, do additional things, and return the in-memory representation of the security token. It's still no claims. It's just token. So it's token-specific, token type-specific structure, like X509 or SAML or Windows, Kerberos. What happens next is we perform some additional validation. Again, you can override what we do there. For X509, we probably do this chaining to actually figure out whether the certificate was issued by some trusted authority. For SAML, we do something similar. We verify the valid from, valid to fields, stuff like that. And once that's done, we extract claims. And for claims extraction from that token, we actually need to figure out what to put into that issuer field. Remember, the issuer is a string. And here, the issuer is represented usually by a signing key that was used to sign the security token. So for translating the issuer's token into a name, we have another component called issuer name registry. Again, you can provide your own. The default one we have is based on the config. I will show how it works later. And in this case, actually, what you saw is this guy returns a local authority, because there is no signing token, because it's Kerberos. It's actually done by LSA. So what goes back is a claims identity. And when you have multiple tokens, you have multiple claims identities. This is why we have multiple claims identities inside the principal. And next step, and this is the step I will be using now, is so once all the identities are created, we know all the claims that are associated with the request. What happens next is we put them all together and create a claims principle that contains all of them, and pass it before we actually authenticate or accept that user. We pass it to what we call claims authentication manager. And that guy can figure out, well, OK, I don't really trust this issuer to say the shoe size, so I'm going to remove the shoe size claim. Even though it was in the token, I'm not trusting it. So it can do things like that. And I can also use it for adding claims. And this is what I will be doing. So I will be actually adding the shoe size claim in this component. So I will be implementing my own claims authentication manager. So what comes back is another claims principle. It might be the same, might be a different one. What happens next is we create a session, usually, because you don't want to send tokens every time. The tokens tend to be fairly big, like especially in the SAML or XML world. So we create a session token that contains the claims that the claims authentication manager returned. Next, we give you an opportunity to do some authorization. By default, we don't do anything. We allow anything to happen. But you can restrict certain operations, certain resources, and implement This is the gate for we call it hosting layer authorization. It returns pretty much true or false, whether the request is allowed or not. And the last thing is we invoke the application code. And we communicate the claims to the user via this claims principle, which is really a principle. So you can access it from this thread.current principle, for example, in .NET. Or in ASP.NET, you can use http context.current.user or page.user. All those things work, and you get claims. So as I said, I will be using claims authentication manager. So how can I do that? It's actually pretty easy. I will be changing. So I will first remove the authorization policy. I don't want to hard code usernames anymore. I want to really use the shoe size. For that, somebody has to inject that shoe size. In this case, it will be this claims authentication manager. So the policy will look like something like this. If it's me, put the shoe size 41 there. And the authorization now can actually say this, OK, only shoe size 41 can access. So I don't care anymore about what's your username, because that doesn't really matter to me. I only want to know your shoe size. So let's see it. So here we are back to the application that we left in the stage where it uses claims but doesn't do the shoe size. So as I said, I need to enable this claims authentication manager. How can I do that? Again, it's a config change. I don't have to change my application logic at all. Actually, during the course of this talk, I will not be touching application code at all. Everything is done in the config and in the infrastructure components by playing with the extensibility points of Geneva framework. So what I'm going to do is I need to configure Geneva framework. For that, we have a special section called Microsoft.identity model. And the only thing I need right now is to uncomment this element, which essentially puts claims. It tells Geneva framework, hey, there is a claims authentication manager implementation. And as you can see, it's actually in my own namespace in that shared assembly. So what I'm going to do now is I'm going to save this. And now I have to implement the claims authentication manager. For that, I'm going to actually implement it in a way so that the only thing I have to change is this claims transformation policy. So I invoke this object from the claims authentication manager, pass it a principle, and returns a principle. And what it does is actually calls transform identity on each identity in the principle that's passed in. So let's take a look at how the transform identity looks. For now, it looks like this. As I described, again, the car is this link statement. It says, if it's Daniel W, insert the shoe size 41. And that's about it. So let's try to build it. OK. Let's try to access the application, and let's see what happens. As you can see, I can access it again, but now actually no the shoe size. So let's see how that actually how this 41 is created. It's really simple. Actually, just use these claims, as I said. It does this. There is a label on the page that says shoe size, and there is a code behind that page. So let's look at that. That sets the shoe size. So it again uses the link statement to get the shoe size. If there is at least one, it puts the first shoe size into the text, and that's about it. So let's go back. So now I have an authorization policy that pretty much looks as I want it. But still, there is something interesting in this application, because that application still knows who has what shoe size. It's not really what I want. The application shouldn't really care about who has what shoe size. It just allows certain shoe sizes to access or people with certain shoe sizes to access the application. So what I'm going to do in the last step is I'm going to move that policy knowledge about which user has which shoe size from the application into the STS. So I'm going to centralize that policy somewhere and externalize it from the application. So the application developer and the application deployer and IT pro who manages the application doesn't have to worry about it. It doesn't have to change the policy in the application every time I change shoe size. For that, I need Geneva server or some STS. In this case, I will be using Geneva server. And the Geneva server, as I said, is one example of this fully fledged security token service. It's a generic security token service. It works in conjunction with the AD. That's the current state that you can get on the Connect site right now. We are thinking about expanding that so that you might be able to use additional attribute stores. But right now, we support AD, and we require actually AD to be there. And it uses industry standard protocols. And as I heard yesterday, we actually support SAML-P protocol or SAML protocol in this web SSO profile as well. And we support both SAML 1.1 and SAML 2.0 tokens. So here's a nice picture with ugly color that shows the Geneva server architecture. The only thing that really, like, there are a lot of things interesting, but the thing that I want to call out is that actually, as you can see, the Geneva server is built on Geneva framework. Which brings an interesting point. Actually, the Geneva framework can be used to build STSs as well as applications. I'm using it primarily to build applications, which is this ASP.NET application I'm showing, but you can also build custom STSs with it. And unfortunately, we don't have enough time in this venue to show it to you here, but we have nice hands-on lab down there where all the bits I'm showing are installed and you can play with them. And there is a hands-on lab that actually guides you through it, the guide. And you can try to build your custom STSs as well. So, and as you can see, we use the SQL for policy store, and we use LDAP and we support AD and ADAM for user attributes and authentication stores. So what I'm going to do now is I'm going to add a STS into the picture. And I'm going to remove the Windows authentication from the application. So what I'm really doing now is I'm federating the claims-based application. I'm making the authentication to happen somewhere else, externalize really the authentication from the application. And instead of that, I will be using federated authentication. For that, I need this federated authentication module. It's actually a combination of two modules, as we will see. And there is another component here, which I already mentioned before. It's this issuer name registry that's responsible for managing the issuers that you trust and giving them the names for the claims. And this one I will use to actually establish trust between the application and that Geneva server instance. And the way it works is there is a signing key that the Geneva server uses to mint tokens. And that signing key has to be registered, or the credential, signing credential, it's 6509 certificate, in that issuer name registry to enable the trust to happen. And something has to happen on the Geneva server as well. I need to modify the policy there to actually know, oh, there is this relying party that has this key that you can use to encrypt tokens for it. And these are the claims they are supposed to issue when somebody asks you for a token for that relying party. So, and we have nice utility called fedutil that you can use on the relying party side to establish this trust, to automatically do that via what we call WS Federation metadata. I will be not showing that part because of the time constraint, so I have it like pre-established. I will just uncomment some things. But again, in that hands-on lab, you can try it with that fedutil, and that guide actually goes you through the establishment phase. Next, I'm going to move the policy out. So the shoe size knowledge now will live completely outside the application. And I will be changing the authentication to actually use, to actually say what that STS can claim. And I will be saying it only can claim shoe sizes. I don't trust it for anything else. And that part is completely optional. If you trust anything your STS says, which is valid in certain situations, you can leave it completely empty. You can leave it as it is, and it will work. But we give you an opportunity to actually narrow down the level of trust that you have in your STS, which is interesting in certain situations, especially on the internet, when you have the self-issued cards. And then the actual flow looks like this. The user authenticates to the STS. The application doesn't really have to care about how. It's the STS business to figure it out. And the user is going to send a SAML token with hopefully the shoe size claim. because otherwise the application will not allow him to access the secret page. So that's the last step. So let's do it. So we are back again in the Visual Studio. As I said, the first thing I need to do is to remove the Windows authentication and replace it with the federated authentication, and then establish trust with the STS. So for that, first of all, I need to go to the IIS manager and disable the Windows authentication on my virtual directory or the application directory. Because I'm done. I'm not going to use it anymore. I don't need it. So next, the other thing I have to do is disable it even here in ASP.NET settings. So instead of Windows, I'm going to say none, because this is a new authentication method that ASP.NET doesn't know about. So in the ASP.NET configuration, you need to set it as there was no authentication, and actually there will be authentication, as you will see. And next, I'm going to add, actually I'm going to replace the claims authentication module that I don't need anymore, because this was only used for existing authentication types that don't produce claims not natively. But I'm adding a module that actually natively produces claims, so I don't need this claims authentication anymore. Instead of that, I'm going to enable this combo of modules. As I said, there are two. One is about WS Federation passive protocol, actually realizes the redirect to the STS and makes the authentication happen. The other one is called Federation Session module, keeps track of the sessions. So you don't have to go to the STS every time you access the web page. And you can use one or the other. And so that's why we split them apart. And I keep the claims authorization there. I'm not going to change that policy at all. It uses shoe sizes, that's fine. That's exactly what I want. So what I have to do next is, as I said, I need to establish the trust with the STS. For that, I have to uncomment this part. And this is the part that the fatutil wizard is actually going to create for you. So you don't have to type it. Of course, you can, if you want. If you like XML, you can type it. The interesting part is this. This is where the trust is established. This is the issuer name registry that contains, there is the thumbprint of the X509 certificate that the STS is using to sign tokens. And this is the name you are supposed to give it. And what this actually does is makes your policies or anything that depends on claims resilient to changes in credentials. Because if the STS rolls over the certificate in a year, you don't have to go to every application and change the policies just because they have hard-coded the certificate in them. You just change this. As Stuart, my manager, usually says, that's a quote from somebody really famous, is there is always one level of indirection that you can add to solve the problem. It's exactly what we have done with this. And then there are some other information about the STS, like where the STS lives, what is the realm of my application. This is the identifier, so that the STS knows what the application, the type or the instance of the application. This is the tokens. When the token arrives, it has the audience URI. This is the audience URI that I'm going to accept. This is my own certificate. So this is here that I'm using to decrypt tokens if they are encrypted. And that's pretty much it. So let's save this. And then I said I need to modify the claims authentication policy. They call it claims transformation policy. So I don't need to add shoe sizes anymore. The STS will do that for me. So I don't need this code. Instead of that, as I said, I will be saying, the STS can only issue certain claims. I don't trust it completely. So I will be adding this code. And what this code does, again, another link statement. In this case, it only allows 3 or 4 types of claims. Name, a shoe size, authentication instant, and authentication method. I will be talking a little bit more about those, so you will see them actually. Those enable interesting scenarios where you actually want to force certain authentication types to happen. Like, you have to use smart card for this operation. And because the user doesn't authenticate to your application anymore, it's the STS to which the user authenticates. You don't know what authentication you use unless the STS tells you. And this is the way the STS can tell you what authentication was used to create claims. So it's pretty interesting scenario. So, and you actually saw one example of that yesterday in Stuart's talk, where there was this high assurance demo. So he was actually able to tell if the user didn't authenticate with certificate, he's not allowed to perform certain operation, and you force the user to re-authenticate with the certificate. And the decision was based on those claims, on the authentication method claims, to be precise. So so we are now pretty much done with the application. The only thing that remains is configure STS, and as I said, I already done that. So I will be just showing you the. So I'm switching the virtual machine to the other one, the server that runs the Geneva server on it, and domain controller. As you can see, there is a policy for relying parties. I have a single relying party here, configured already, which is this application. You can tell by this identifier. And there are certain things I can say. So this is the application certificate. This is the issuer certificate. Those are the claims I'm going to issue. As you can see, authentication method and authentication instant are automatically added. You don't need to configure anything. And there are some delegation I'm not using and policy monitoring for automatic management of the trust. Unfortunately, I cannot show you in the UI the actual policy because the UI is not capable enough right now. But I can show you how that policy looks like. This is interesting. Oh. I don't know what happened, but it works now. So this is a language, actually, that we use. It's a language. I wouldn't call it language. It's just an XML processing instructions, really. And we are still working on it. So this is what the beta 1 uses. And as you can see, it matches the claim. In this case, it's name. It issues a new claim, which is the name. And also, it issues another claim, which is a shoe size, as you can see here. Not this scroll bar. But only if the name is this. And as you can see, we use regular expressions to actually decide who can access, to match. So you can do some interesting stuff there. And I replace it with 41. So this is where the knowledge about the shoe size is recorded now. And as I said, and I will be talking a little bit more about it, you can actually fetch this from LDAP or some other attribute store. You don't have to hard code it in the policy. It's just I use it now to demonstrate the language. OK, so let's go back to the application and see whether it actually works. So it should work, right? I disabled Windows. I changed the policy. I'm closing this window because this window still thinks it's Windows. I'm going to open it again. It recompiles in ASP.NET all the pages. Here we go. Default page. Again, I'm anonymous. Nothing really changed. So let's go to the secret page. That should force the authentication to happen. So I now will be redirected to the STS. Here we go. Actually, as you can see, the ASP.NET login name still works. And there are shoe size. I have shoe size. And there are other interesting claims. And as you can see, well, OK. I haven't recompiled the application, so I'm adding it. Still adding the 41 claim. And the other 41 claims is issued by the STS. And it's actually interesting. Now you can see why we have issuer on the claim. Because I can have claims from different issuers in the single identity. They can be collected along on the way. They can be added from multiple sources. So I can actually mix different claims from different issuers on the single identity, and it works. That's one of the things that didn't work in WCF. And that's one of the reasons we added issuer on the claim class. So that's the demo. And now let's continue a little bit more about what you can actually do with it. So I will be more talking now. And so what you just saw is this. So I externalize authentication to the STS. I externalize the claims gathering to the STS. So the application doesn't have to care about where the shoe size comes from. And the only thing application cares about is that the right and the proper shoe size is used to access the resource. But I can do this because I externalize the authentication. Imagine this scenario. If another user, that user doesn't sit in my network. He's actually not even my user in that enterprise. He's a user that has identity in the Windows Live ID or the cloud. So now, Windows Live ID can have a STS, it actually has a STS. It can mint tokens the same way Geneva server does that, using exactly the same protocols. And the only thing I need to do is establish trust between those two STSs. Again, I don't have to change the application. Even I don't have to touch the policy on the application. And now the user authenticates to its STS, types the Windows Live ID password, or it can use card space. Then it's redirected to my STS that I actually trust. That issues the right claims, in this case the shoe size claim, and the user accesses the application. If he has the proper shoe size, it will work. You don't have to touch the application at all. And that's the power of federation. Because when you externalize authentication from the app, those things can happen, and you don't have to worry about them anymore. That's one of the very interesting, very compelling reasons to do the federated thing. The other thing that you can do with claims is identity delegation that we introduced in this beta. And for that, we need to go back to claim and to that object model. So I missed one property on identity that's pretty important. It's called delegate. That property actually can point to another claims identity. And the semantics or the meaning of that is, oh, this is the user who is accessing, this is the caller, but in fact, the call is actually made by somebody else who the user delegated. And that's where the delegate property points to. So this is how your application can reason about chains of like call stacks, really. If I go through multiple intermediaries before I reach the backend service, even the backend service can see who is actually sitting behind the browser, and it can actually see the whole call stack of all the intermediaries, all the identities about, and can restrict or make some interesting authorization or personalization or other decisions based on that information. And if it doesn't care, if you don't have to even think about the delegate property, and it will still work, because it will look exactly as the user that's sitting in the front end. So how it actually works on the wire, the beauty of this is we haven't really changed the protocol. So we haven't created some one-off or some special case. Actually, really naturally extended the WS trust protocol with a single XML element. And it was all it needed. And that XML element is actually in the standard version of WS trust. So we just used it, really. So what happens is the Bob accesses the web front end, which is ASP.NET application. And that ASP.NET application, in order to fulfill the request, needs to go to the backend, which in this case is WCF service. It's exactly the demo you saw yesterday. And so the Bob's authenticated to the STS either via card space, it can be Live ID, it can be Kerberos, it doesn't really matter. And accesses the web front end. It says, hey, I'm Bob. The token says, I'm Bob. So what the web front end does, before it can access the backend, it needs to get a token, right? Because it has to authenticate. But it obtains the token in a little bit different way. It doesn't say, hey, I'm Bob, and I want, it doesn't say, hey, I'm web front end, I need to access the backend. It says, actually, I'm web front end, and I want to access the backend, but I want to act as Bob. Because that's what I'm supposed to do in this situation where there is a middle tier there. And what gets back is a token that says, this is a Bob, but he actually delegated web front end to do that. And that token is only issued if the identity of the web front end is actually allowed to act as a delegate of Bob. So there is a policy behind that STS. And you saw that when I showed the Geneva server management console, there is a delegate tab on the relying party. And you can configure where the application can, what other applications, the backend applications, the middle tier can access. So right now we are on the par with what in AD is called constraint delegation as far as the policy goes. But our plans are bigger than that. So we can do better because we actually know the Bob's identity as well. And we can restrict even for what users the web frontend can actually delegate. Can be delegated. OK, so that's pretty much what covers what you have in the beta right now. I just, as you saw, I'm mostly talking about ASP.NET, but all the things I showed, all of them, besides the modules and web.config, work exactly the same way in WCF. And so we have some broader plans, right? So what you saw is authorization. Okay, well, you still wrote code. So I have to recompile the application every time I change authorization. But that's not really what I want to do, right? And we agree. That's really not what we want you to do. We don't want to do that even ourselves. So in the future, what we want to do, imagine this is the code I use for the hasClaim method. It's link and figured out what the value, and then this one actually does, it checks only my name. Imagine that turned into this. So you just decorate the method with the attribute. Says, hey, this method requires access check. And by the way, the only thing I'm going to tell you is this is the method name, and this is the operation. Or this is the resource, and this is the operation. Or whatever, however you want to slice it, there is this REST versus RPC, right? Depends. Doesn't really matter. So you are not actually saying anything about the policy. Zero. There is no shoe size. There is nothing. Everything is taken care of similarly to the authentication. So authentication, we already did that. We externalized authentication to the STS. So next, we are going to externalize authorization somewhere completely outside your application. So you don't have to even worry about it. The only thing you have to do is identify places in your application where you want to perform access check, the guarded places. And that's it. So that's one feature. That's on the framework side. On the Geneva server side, we have some enhancements that we want to make. One thing is that policy language I showed you. The XML, you can access only certain properties on claims. We want to make it more. We want to be able to access more properties. We want to be able to ask for more complex things, like you have to authenticate with X509 and have this username in order to get this claim, things like that. Custom attribute stores. That's one of the very frequently requested feature. I don't store my attributes in LDAP or AD. I store my attributes in my custom database, or I store my attributes in SAP. And I want to create it. I want to flow them in the system as claims. How can I do that? That's this feature. We want to provide some analysis so you can actually reason about what that policy does without running it. Some more about delegation. And you want to be able for you to extend the process of token issuance so that you can actually do some custom steps as well in that pipeline on the Geneva server. So that's the Geneva server. You might be asking when I'm actually going to get that. So besides those blue slides, as I said, the blue is, I cannot do any promises right now, but the black slides, you get a beta 1 right now. It's available since Monday. You get a beta 2 in the first half of 2009, and we are shooting for RTM on the second half of 2009, where framework, card space, and the server will all be available for general use. And all of that is under the Windows license, which I believe I have a slide here. So you don't have to pay any more than you pay for Windows. You get everything that I just showed you and more. Supported platforms today, in beta, we support only Windows Server 2008 and Windows Vista. And we encourage you to give us a feedback which platforms you want. We have a launch, we have a hands-on lab. As I said, we have 2 booths where we can show you a demo. Look for people that wear the same shirt as I. They can answer your question. All the questions you will have, hopefully. So what I want to, really, when you leave this room, what I want you to take with you is 3 things. The claims are good. The STS is there to help you with them. And we give you a consistent programming model that works everywhere. For now, it's WCF-ASP.NET, and we will be making some more announcement later in the future. I cannot really say anything about it right now. And there are some other sessions that are on this. And that's pretty much it. So if you have any questions, we have, I believe, another, how many? 15 minutes left.
I would like to ask a question. With all the cloud services, the access protocols are through RESTful APIs. With these identity services, it is through WS Trust. So can you comment on that?
Well, yeah, so today the observation is absolutely right. Today the WS Trust is SOAP-based, RPC-based protocol, but we are looking into enabling scenarios where you could actually write, let's say, JavaScript to obtain a token. And again, I cannot talk much about it because we don't have anything baked yet, but we are definitely looking into that space. And we are thinking about as well. So you heard that announcement that we made about Live ID supporting OpenID, and so we are going in that direction as well. And so definitely today, unfortunately, it's pretty hard. It's actually we have a code that does that even in JavaScript, but it's clunky because it's XML, it's SOAP, and yeah, we definitely want to do better than that.
Have you tested interop with Sun's identity products?
Yeah, well, we are continuously doing interop testing. We already started that with WCF, and we have pretty good relationship with Sun. And that interop continues. And we actually have a federated identity.net site in the cloud that uses those products, and we use that for open interops with whoever is interested. So yes, definitely. It's very important for us to be interoperable with the industry.
Which of the SAML bindings do you support at the moment?
As I said, just the web SSO profile, and I believe the beta one is only in the identity provider role. We are looking into providing the service provider role as well for the web SSO profile, and today we don't have any plans to go beyond the web SSO for SAML-P.
For your custom attribute stores, like you said, right now you support is LDAP. Are you planning on supporting anything for RTM, or is that just up in the air at this point?
Yeah, I don't know. Okay. We are looking into it. I cannot give you any concrete answers right now.
Yeah, I guess something else that might be along the same lines. And just to clarify, you mentioned WCF and ASP.NET. What about any thick client Windows apps? Is that still up in the air?
Well, you will see one interesting demo on Thursday. I don't want to really reveal it completely, but we actually hooked into SSP, and we added this federated module inside a service security provider in the LSA. So any application that uses WinINet, RPC, can actually be federated now. And we will see some demo, pretty cool demo on Thursday.
Okay. And I guess just one other question about federation, and something I'm not quite sure of, is you mentioned that you could set up a trust between your STS and Windows Live ID.
Yep.
What's involved in that?
Again, the same thing. You probably have to register something. I'm not from the Live team, so I encourage you to visit that booth and ask exactly. But technically, it's the exchange of WS Federation metadata documents.
Okay.
So they expose WS Federation metadata where they say, this is the key I'm going to use to sign, this is the set of claims I'm supporting, and you can have your own, and you send it to them, and hope that they will give you the right claims.
Okay, thanks.
Hi. Can I write custom code for the Geneva server to do my claims transforms and authorization policy?
That's one of the things we are looking into for the RTM. Right now in beta 1, no.
All right, thanks.
There was something that sort of puzzled me in the demo. On one hand, you had in the web config file a trusted issuer element where you defined which issuer you will trust with the a readable name STS1 and then its fingerprint. But then in the transform identity C# function, you explicitly did if C issuer equals STS1.
Yeah.
I would have assumed that you don't get any claims if they don't come from a trusted issuer, or do you need to manually make sure that the issuer is actually the one that you trust in that code as well?
Oh, that's a good question. So there are two steps involved in authenticating the token, as I showed it, as far as issuer is concerned. One is the issuer name registry. So if we actually don't find, or the issuer name registry tells, I don't know anything about this token, then we throw immediately. We just reject the complete token, all the claims. The user doesn't even get further. And if the issuer name registry says, oh, I know this issuer, which means it's trusted, like if the issuer name registry, let me put it this way, if the issuer name registry is willing to give the token a name, it means it's trusted. So it can proceed further. So we extract claims, we put the name on all of those, and then we call this claims authentication manager. And then that component can do some additional checks. And it can be completely empty. You can leave it empty, and then everything will go through. Or you can constrain it even more. So you can say, this issuer can only say this, like the shoe size.
Right. So since in this case there was only one trusted issuer, the extra check was in fact not really necessary. Okay,
yeah.
Thanks.
How would we implement kind of authorization that is object-based? I'll have authority to perform some operations, but only in certain objects, not all objects. So I have a claim that I can edit a particular object, but only a subset of those objects. So it's an identity that somehow only the application know how the STS would compose a claim that would have those identities that it can manage, for example.
Well, I will try to repeat if I get it. So in my words, you have some resource that you don't see from the invocation. So I go to a page, but that page accesses like 3 resources.
An example, I have a network administrator. I can change IP addresses, but only in the United States. You cannot do that in.
Location.
Yes.
Oh.
Yes.
That's really cool
or any
scenario.
other partition of objects.
Yeah, that's a really very, very interesting scenario, and there is no reliable way right now to figure out the location, and we're definitely looking into enabling that. But you have to understand this includes a lot of components. So going from the network stack through firewalls, through like security in the buildings, stuff like that. Everything has to be connected so that you actually can figure out, oh, this user is sitting in this building in this country. So, but once the firewalls, the network stack, and all those components will be able to make claims about identity. So you can imagine as the message goes through the firewall, for example, it can see, oh, it's coming from this intranet, and therefore, and because this intranet is located in this building, and like I know where the user is.
Right. The question was not about location specifically, but if I have, I can do a certain type of operation, just like an ACL, but only on this subfolder, not this other subfolder. So is there a way to use the claim system for this type
Absolutely, absolutely. But as I said, the authorization right now in beta 1 is pretty weak. We basically say, go figure out. So we give you claims. Whatever claims you need, you can tell us, and we will make it happen. But from that, once we give you the claims, you are basically on your own. And one of those blue slides actually is about extending that story so that we can help you even more with the authorization. Right now, you have to code it yourself.
Okay, thank you.
So, thank you very much for coming.